Today, we're really diving into a topic that's causing a bit of a stir in UK development, PFAS contamination. So, picture this. You found the perfect spot for a big project, and then bam, you discover it's just full of these practically indestructible chemicals. Talk about a curveball. And joining me today is our expert in environmental science and brownfield redevelopment to, help us get to grips with this whole thing. Welcome.
Thanks for having me. Glad to be here.
It's a bit unnerving, isn't it? The thought of these forever chemicals, as they're called, hanging around unseen for decades. We're talking about things we use every day, like non-stick pans, firefighting foams, that sort of thing, right?
Absolutely. PFAS, or per- and polyfluoroalkyl substances, they've been in wide use since about the 1940s. Those unique properties they have, the resistance to heat, water, oil, it's made them so useful in a whole range of products. But now we're starting to see the downside, that those same properties make them stick around in the environment. Well, forever, really.
So it's like we're dealing with this, chemical inheritance from the past, especially with brownfield redevelopment. It's not just as easy as clearing an old factory site anymore.
Right, you've got it. These sites, they often have a history of PFAS use. Everything from how things were manufactured to, fire safety measures. Just as an example, there was a study recently, they looked at a former airfield, I think it was in the Midlands, where they'd used firefighting foam, and it caused a real PFAS problem in the surrounding soil and groundwater. What they found was these chemicals had spread beyond the site itself, which shows you how tricky this all is.
It makes you realize that PFAS contamination, it's not just limited to certain industries or places, is it? But before we jump into the nitty-gritty of cleaning it all up and the regulations, let's break down what actually makes PFAS so different, so persistent. It all comes down to their chemical structure, right?
Definitely. Imagine like a chain of carbon atoms, the backbone of so many organic molecules. Now with PFAS, every single carbon is super tightly bonded to fluorine atoms. And this carbon-fluorine bond, it's one of the strongest you can get in organic chemistry. It creates almost a shield that makes PFAS practically immune to those natural processes that would break them down.
So they're like the superheroes of the chemical world, indestructible.
Well, maybe not superheroes given the potential problems. It's more like imagine chucking a plastic bottle in the ocean. It might break up into smaller bits, but those plastic molecules, they're still there. PFAS are similar. They can travel huge distances, hanging around in the soil and water for decades, centuries even, without really breaking down.
It's a scary thought, isn't it? And it's not like we're dealing with just one PFAS compound either. It's a whole family of them, right?
Exactly. There are thousands of types of PFAS, each with their own quirks and potential risks. This is what makes detection and remediation such a headache. It's not a case of just testing for one thing. We need to look at the whole picture, understand the exact mix of PFAS at a site, and how they act together.
So it's a real tangled web we're trying to untangle here. And it seems like this PFAS contamination, it's a ticking time bomb. What's the situation with regulations here in the UK at the moment, and how are we dealing with this PFAS legacy?
You're right. It really is. It's like we're racing against the clock. The good news is, well, people are finally waking up to the PFAS problem, and we're seeing stricter rules being put in place. Here in the UK, we're gradually phasing out PFAS in different areas, and the limits for PFAS in drinking and surface water are much stricter now.
That's good to know, and this might be a silly question, but with these chemicals being so tough to get rid of, how do we even begin to clean up the mess that's already out there?
The million-dollar question. Unfortunately, the usual methods we use for other contaminants, they just don't work on PFAS. It all comes back to that super strong carbon-fluorine bond we talked about earlier. It makes them incredibly resistant to breaking down.
So it's a bit like using the wrong tools for the job then.
Exactly.
Yeah.
Take bioremediation, for instance. We use microorganisms to break down contaminants, but they just can't digest PFAS properly. It's like, trying to eat a plastic bottle is just not going to work.
So we need something completely different, new tools in the toolkit. What are some of the promising methods being developed?
There's some pretty interesting stuff happening right now. One that's looking good is called soil washing. It's just what it sounds like, really flushing out the contaminants using a special solution. This solution, it binds to the PFAS and pulls them out of the soil.
So a kind of deep clean for the soil then?
Exactly that. And there's another method, stabilization or solidification. This one's about injecting a material into the ground, and this material, it grabs onto the PFAS, locking them up so they can't seep into the surrounding environment or the groundwater.
So rather than removing them entirely, it's more about containing them.
Yeah, exactly. It's all about managing the risk effectively. But it's not just those. There are even more advanced, almost futuristic techniques on the horizon.
Really? Tell us more. What kind of futuristic techniques?
Well, one of the really exciting ones is called supercritical water oxidation, or SCWO. It uses incredibly high temperatures and pressures to break those tough carbon-fluorine bonds. Basically, it destroys the PFAS molecules completely.
It sounds pretty amazing, turning these forever chemicals into something harmless.
It's getting there. And then there's senolysis. That uses sound waves, believe it or not, to make tiny bubbles, and when these bubbles implode, they release enough energy to break down the PFAS.
It's incredible to think about these advanced solutions. It feels like we're on the verge of some major breakthroughs in cleaning up PFAS. But with all these options popping up, how do we decide which approach is best for a specific site?
Well, it's a bit like, I guess, choosing the right tool from a toolbox. Each brownfield site is different, isn't it? Different history, different contaminants, different goals for what they want to do with it.
So a one-size-fits-all approach just wouldn't work.
Not a chance. A really thorough assessment of the site is crucial. We need to figure out what types of PFAS are there, how much of them, the soil and groundwater characteristics, and of course, any potential risks to people and the environment. Only then can you develop a plan that's tailor-made for that specific site.
It sounds incredibly complex, like solving a giant puzzle, trying to find the right combination of assessment, regulation, and remediation to really tackle this thing head on. But what about the bigger picture? What does all this mean for the future of brownfield redevelopment in general? It does feel like we're at a turning point, doesn't it? Trying to figure out how to redevelop these sites responsibly with this PFAS problem looming over everything. But before we get too lost in the weeds, I think it's important to, bring it back to our listeners for a sec. What's the key message here? Why should anyone listening be concerned about PFAS and brownfield redevelopment?
That's a really important point, and it's something I feel strongly about. This isn't just some, abstract environmental issue or something that only developers need to worry about. PFAS contamination, it can actually affect all of us.
How so? Can you explain that a bit more?
Well, think about it. These chemicals, they can move from contaminated sites and get into our water, even our drinking water. And because PFAS are in so many everyday products, they can get into our homes and even our bodies in different ways. So understanding this issue, it helps us make better choices, whether that's pushing for stronger regulations, supporting sustainable development, or even just being aware of the products we're buying.
So it's about recognizing those links, those hidden connections between us and these bigger environmental problems.
Exactly. Knowledge is power, right? The more we know about PFAS, the better we can protect ourselves, our communities, and the planet.
It's about everyone doing their part then.
Absolutely. We need scientists doing cutting-edge research, policymakers making effective rules, and developers using responsible remediation methods. But it also comes down to individuals like us staying informed, asking the tough questions, and demanding action.
It's a team effort to build a safer and more sustainable future for everyone. Well, as we wrap up this deep dive into the world of PFAS and brownfield redevelopment, is there one final thought you want to leave our listeners with?
Despite all the challenges we've talked about, I'm actually feeling quite optimistic. There's a real global shift happening, a growing awareness of PFAS, and it's leading to incredible research, innovative technologies, and a real determination to solve this problem. It's a tough one, that's for sure, but I do believe we can crack it if we work together.
That's a really positive note to end on. A huge thank you to our expert for shedding light on this complex and, let's face it, concerning issue. Remember, knowledge is power, and your curiosity is what keeps us exploring. Until next time, keep those questions coming, stay informed, and most importantly, stay curious.